Well, it was actually my first time to be a YouTuber to make that video 2.5 years ago. I hope you enjoy it. Thank you very much. And you can, in a casual way, do it yourself, weather prediction. And let me explain again what happens behind, or after you have ordered the job, where are the resulting data? You order the job, and then the job runs in the compute node, and then the compute node write the data to your storage area. And then it has a very complicated path according to the system. So we provide a user interface tools for you to get the path. Here you are. Please, now please use your browser, and we will use the Jupyter Hub again. So maybe this is time you use a second screen, or make your shared screen smaller, and you use a browser. Okay, the tool we provide is from the package CPAS.ui. So from this package, you import this class called capital letter UI. And then you instantiate an instance of this UI class by adding a blanket here. Usually we call it a constructor of the class to instantiate an object. And then you have a UI object. And the API is designed in a cascaded way that you can call the select job method, and then it still returns the UI object to you. Let me read the chat. Somebody may have question. You hit simulation fail. Requested data source is not available. Right, there is a time delay for the American GFS system to distribute the data which CPAS used as the initial condition. So when you order a real simulation job, make sure you order a job with the initial condition several hours ago. I guess this is the course if you order a job that is really within 6 hours as of the current time. Otherwise, there may be some system error like we cannot download GFS data from their website or something like that. Then you will have failed real simulation job. So my advice is for you, it is 12 now, and then it just passed 4 hours. So in the afternoon, you try to order the same job again. Hopefully, the data from the United States arrived our system. Thank you. And then this UI will display something. Well, let us do it together. So let me escape from full screen. And then I put the slides to the chat so that if you really don't want to type the code here, you can see exact spelling of every word. And then we go to the notebook. You go to My AmberScript Learner, and then you use a new notebook for a new lesson. Here, if you still remember, from CPAS.ui, the package provided by us, import UI, and then press enter for another line of code. And then you instantiate it by calling it in constructor, and then it will be the object, and then you call the select job method of the object, And you need to use this object later. So you assign it to a variable. You put a assignment equal sign here, and then put the variable named UI. This should be good. And then you press the run button. It is running. Let me, okay. This is the user interface we provide. Previously, I named my mesh to be something like Hong Kong to London. And then if you have run simulation job, you will see that it found data files. Spec.json is the specification JSON file I just mentioned. And then grid.nc is the generated unstructured mesh. And then if you have already ordered a successful real simulation job, you will see more data files. Static.nc is the file containing static data. Static data include terrain data, land use data, soil data, something like that. Static, it does not change a long time. And then init.nc is the initial condition, which, as I said, we get from the initial condition data you specified, either GFS or for if you want to simulate something in the past, you may also select the ERA5, the European reanalysis data set. And then DIAG stands for diagnostic variables, which are output of the simulation. So if you see this screen, you have actually successfully found the data file. So the next thing is we want to get the generated mesh. So in the UI object, and then you type dot, and then you can actually type tab to see what can be offered by the UI object. Usually, there are too many things offered, and you cannot remember which one is which one. So I get to tell you, the grid file is grid, something, and you tap again. Tap OK, auto completion. It is the grid_nc file that contains the path of the found data. So you hit the run button again. You will find the path of the generated grid of your grid. So now you have the path of the generated unstructured grid. What you have learned in the last lesson, you can use X-array to open a net CDF file. So try to remember how to do it. I give you 3 seconds before I show you how to do it. Okay, you try to type your code in your code cell. Okay, here is my answer. Firstly, you need to import X-array as XR, enter, and then usually the resulting object is a data set object. So the variable I use is DS, and then you will be using X-arrays method or a function called open data set. Okay, and then open bracket. You now you need to put the path to it. So you can copy and paste, but this is a long path. You can just use these variables. Anyway, this variable contains the path. And Python is usually user-friendly. It is not actually a string. It is actually an object called PostGIS_path. And you may try whether the X-array open dataset function is smart enough to ingest this PostGIS_path object as its input argument. So now you run it. Oops, error. Now, let me do some kind of picking. Let me show you the good thing. I have already prepared a notebook inside the shared subdirectory, and this notebook can be run in a read-only way. So now you can navigate to this shared ATM Learner subdirectory. Now, in addition to Jimmy's work, you see my work, lecture 2, you go inside. And then lecture 2, unstructured mesh triple notebook. Okay, here is the code I prepared. It starts with the code avoiding warning that will distract me. And then let me, okay, choose another one. Okay, this one has match and also simulation results. And then, okay, this time I am successful.